Okay, on this great day, we're going to be multiplying special cases. And there are going to be two cases that we're going to look at that will be foundational for the rest of your mathematical career. So today we're going to use patterns to multiply binomials, which means if we're using the pattern, you don't actually have to show any work. So real quick, as you multiply things out here, I just want to show you that you would have gotten c squared plus 2c plus 1. This one here would have gotten you x squared plus 6x plus 9. After you multiply this one out, you get n squared plus 10n plus 25. And down here, x squared plus 20x plus 100. And this one here, a squared plus 2ab plus b squared. You could have used the grid or used double distribution. If you had used double distribution, it would look something like this. X times 3, 3 times x, 3 times 3. Combine your like terms. So what we notice is that there is a pattern that does show up. In fact, right here, E is going to be our the square of the binomial pattern. So it looks like this. If you have a binomial, we'll call that a plus b, and you square that, it always will give you this, a squared plus 2ab plus b squared. That sounds a little bit confusing to begin with, but let me show you the M that always helps me. The M that always helps me. First off, when you see that you have a square right there, a binomial squared, you can just use this little M pattern here. You take the a and you square it. So you get a squared. Then you multiply these two things together, a times b, and you double it. So first you multiply them, and then you double it. So here we get 2ab. And the last thing you do is you square this. The b squared gives you b squared. So if you notice, it's sort of this M pattern here. Square the first thing, multiply and double to get this guy, and square that. A common mistake here, and let's write that over on the side, a common mistake when we see a plus b quantity squared is that we want to send the 2 in like that, and we say a squared plus b squared. And you have to say, wrong. It's a common error that we make. There is no distributive property in this case for an exponent, okay? Notice that, remember, when we're looking at this, it's an a and a b, and if you do a grid, you'll see it a little bit easier, and an a and a b there. So that means you have 4 terms that have to be multiplied. I have an a squared, I have an ab, I have an ab again, and I have a b squared. So notice that this ab term shows up when originally I didn't even see it. I don't see an ab here. I see an a and a b, but not an ab together. Well, that's the idea of the pattern here. And you can use this M pattern here to do that. Worst case scenario, if you forget the rule, you can just do double distribution again, or grid method here. But square of a binomial shows up a gazillion ways. And before we're the end the year, we're going to be going backwards from here to here in order to solve more advanced type problems. So again, this is a foundational thing. A visual model, let me show you that. In fact, a visual model is essentially the grid there. So let's just set that one up. What that might look like if we call this, if this is length A here and this is length A here, this is length B, and that's length B there. Notice I'm intentionally making them like different sizes. The A is longer than the B, but it doesn't have to be. The B can be longer than the A. So notice it's essentially what we just did. If this here is a square, that's A times A. So clearly we see that this area model is A squared. And next we see that this guy right here is inside there is just b by b, b times b, right there, b times b. So that there is a b squared. So, but notice the two things that aren't accounted for. The two things that aren't accounted for. Well, this is a b here times an a there, and that's a b here times an a there. So just to show you where things come up, the a and the b both show up there. The area of this rectangle is AB. The area of this rectangle is AB. So these two rectangles are the same. They're congruent. This is a square, that's A by A. This is a square, that's B by B. And when we add all four things up together, we get the A squared, plus we have two ABs, plus we have a B squared. So this is the idea of where it comes from. Again, if you want to consider it as this is a closed book, you don't see the inside pages. This is an open book, you see the inside pages. Because a lot of people struggle with, where does this middle term come from? It's like the pages of a book. You can't see it very well when you close the book. So hold fast to that analogy. Now let's use it. Let's use these. And these are very fast patterns, pretty much. There's not much work to show. In fact, if you can do it without work, that's okay. I'm going to show you an intermediate step for each one of these, but you don't have to do that intermediate step. So using my M pattern, I just take this and I square it. So I'm going to write that down so that you see what's happening. 2m squared. Notice the 2 and the m are both squared. Next, we have to multiply these together and then double them. So when I multiply them together, I get 2m times 5, and I have to double that on the outside. So I put a double out there. Multiply them together and double them. You can do that in your head. I know you can. I just wanted to write that so you can see it. And this guy here, I just square. So I bring down the plus and a 5 squared. This, like I said, does not have to be written. You can skip this part here. In fact, I'll write the word optional just on the side there, or mental, whichever way you prefer. That's just optional there. But now let's go ahead and simplify out. 2m times itself is 4m squared. 2 times 2 is 4. M times m is m squared. Now when you multiply this stuff out, 2 times 2 times 5, or 2 times 5 times 2 is 20. And then the m comes down. And lastly, 5 times 5 is 25. Box or circle your answer. Again, the middle part is just a mental thing. You can just do step by step. Square this guy, put it there. Square this guy, put it at the end. Multiply these together, 10m, and double it to get 20m. There we go. Let's do this one without the middle step. I just have to take this guy and square it. 5x times 5x is 25x squared. Then I'm going to multiply these two together to get negative 15x and double it. Multiply to get negative 15x and double it to get negative 30x. And last, I square this guy right here. Negative 3 times negative 3 is positive 9. And there we go. Square, multiply and double, and square there. Notice a negative here is being squared to get a positive. But when I multiply and double this, the negative stays with it. Now check the work here. What we're going to do is show you that this can be used to do some mental math and do some math fairly quickly. So we're going to walk through two examples of how to do squares. If I had 32 squared, in my head, most likely I would probably, if I had to multiply this in my head, I wouldn't do it in my head. I would do this, right? And then 4 there and 6 there and bring down the 0, blah, 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 right? So let's see if we can speed that up with this method that we now have. Notice that 32 is 30 plus 2 squared. And why is that nice? Well, because I can do operations with 30 pretty easily, and I can do operations with 2 fairly easily, especially in my head. So in my head, square this. 30 times 30 is 900. That's an easy enough number to deal with. Multiply these two to get 60 and double to get 120. And square this to get a 4. So this could have been done completely in our head because 900 is easy to remember, 4 is easy to remember, and all 120 is just keep that in my head there. So this is 1024. 1,024. So 32 squared is 1,024. You're welcome. Now let's do the exact same thing here, but 28. 28. How can we rewrite 28? Well, 28 can be 25 plus 3 or
20 plus 8.
20 plus 8, that could work too. Or 30 minus 2. But if you had said 20 and 8, that's fine too. 20 plus 8. That would have worked as well. We would just do the square here, multiply and double, and do the square there. Okay, that would still work. But let's see either method. Let's do them both. This one here we already know is 900 when we square it. Multiply and double to get negative 120. And this one's a 4, a positive 4. So 900 minus 120 is 780. And then we add 4 to that. 784. Now, had we taken your suggestion and done the 20s, we would do 400 here because 20 times 20. Multiply and double, so this is 160 to get 320, and that's a 64. I don't like those numbers as much, but it would still work. This one here becomes 720 plus 84, or 64 is 784. Good. Either one works. So we can do squares pretty quickly. Instead of this way right here, we can just split them up into nicer numbers to manage. Your turn. Go ahead and attack A and B. Go. Now, the 71 is 7 plus 1, and then 4,900. Multiply and double to get 140, square to get 100, add them together, 5041. Notice over here is 10 plus 8. So, square, multiply and double, and I should erase that there. And then square, 64. So we get 260, so 324. And there we go. Almost completely mentalable.